right, my friends, on this one, you could also have done a t-table like we have in the past. So I hope it makes sense that your inputs would, these are functions of y, so it kind of makes sense that you would put things in for y. And then, just square your y value and then double the results. So 0, 0 would stay 0, 0. Square plus or minus 1, you get 1, and then double it, you get 2. So that would turn into those points right there. And then square plus or minus 2, you get 4, and then double it, you get 8. And so that would turn into, let's see. Okay. Here we go. And then, try to fill it in there. Okay, I'm going to have more than one graph on the same plane. So I'm going to label this one with its equation. There we go. Okay, now what did we notice? What effect did that 2 have to what would have been just a normal x equals y squared graph? I hope it makes sense that the 2 serves as a stretch factor. And as a matter of fact, if you were to take this picture and turn your head 90 degrees to the right, it would look exactly like what would have happened to a y equals x squared graph if we had multiplied x squared by 2. So with that said, I just want to point out that we kind of prefer to have our stretch factors as a coefficient of your squared term. Just because of kind of the way that we've been trained. So for that reason, I think most of us probably divided both sides by 4 with part B, and so that you could have that little stretch factor on the squared term side, so the coefficient of the squared term. So when you graph x equals 1/4 y squared, it still has no shifting is occurring here. And then from here, I'm just going to think, okay, well, I'm going to go, to plus or minus 1 on the y-axis. And then how far over would I go? Well, you would have gone over a fourth of a unit. I'm trying to make that look convincingly like a fourth, but it's a little hard. And then, what happens if you had put plus or minus 2 in for y? Well, instead of getting 4 out, like you normally would when you square it, you'd have to take a fourth of it. So you'd only get 1 out when you put plus or minus 2 in. Now, some folks don't like filling these in with just 5 points of accuracy. So what you could do if you're feeling a little naked is you could always plug in something like plus or minus 4 in for y. So we'd get 16 for the y squared part, and then you get a fourth of that. So plus or minus 4, and then you go over 4. So some people kind of like having a little more to aim for. For that. So really with this example, we're just making sure that you'd be okay. Actually, that you're going to be okay with stretch factors if you have x equals y squared as your parent function. So, and then part C is a fun one. You get to divide both sides by -9. I personally would write it as x equals -1/9 y squared. And then this time, put 0 in, you get 0 out. Put 1 or -1 in for y, you get -1/9 out. 2 or -2, you get -4/9 out for x, which was what, just a little less than a half. All right, let's put plus or minus 3 in for this. You'd finally get 1 out. After, you square it, then you multiply by -1/9 type thing. So anyway, you could always put plus or minus 6 in, and then you could get -4 out. There we go. So this time you had what would that be called? A horizontal shrink. Yeah, a horizontal shrink and a reflection over the y-axis as well, since your leading coefficient was negative. Okay, and then let's label this one. Okay, so at this point, hopefully you're feeling comfortable with, first of all, if you have a multiplier, like a coefficient, the idea of moving it to the squared term side. And then next, hopefully you're okay, where with an x equals y squared parent function, If you are multiplying your squared term by a positive, that would make your parabola open to the right. And if you're multiplying your squared term by a negative, it would make it open to the left. So hopefully you're doing okay with that. Okay, now a big deal here is, before we go on to the next example, let's complete this. Stretch factors for parabolas should be coefficients of which term? So go ahead and fill in the blank and then check in with me in the next video.